All right. Hello, ladies and gentlemen, and welcome, welcome, welcome. People are coming in. Let me pull up the chat. There we go. Feel free to post on the chat who's coming in, where you're from. Thank you for the comment about the music. I hope I will keep the volume at such so that we hear it, but maybe it won't be distracting. That's my plan. All right, we've got a decent number of participants out there. I want to kill another minute or so. So while I am doing that, because people are still logging in, I want to show you what's going on here in Long Island, New York. This is a video I shot 3 minutes ago. So there is Cookie Jelly Bean at her usual spot in the front window, and you can see the snow coming down. In the background, we are getting snow here in Long Island. And watch the dog. The closer you get to the dog, the faster the tail typically waves. That's the way it works. You get closer to the dog, the tail wags faster and faster. So for those of you who have a dog, you know exactly what I'm talking about. Let's see. I'm going to pull my participants list and everything over here. I think we're about ready to go. We've got a good number of participants. People are checking in. I do ski, thank you. Not well, but good enough just to keep my my son into it. Now, it's funny, I didn't realize when I became a father that I'd be the one responsible for like having to go on the roller coaster when they want to go on the roller coaster and having to like ski down the Black Diamonds when they want to ski down the Black Diamonds. All right, so here's how I want to start our day. Basically, I want to start with a big thank you. Okay, so this is called in the business a cheap pop, right? It's easy to get applause when you're thanking someone else. You know, Cassia has been spending the day thanking all of the presenters for all of the work they've done, for setting up all their presentations. You know, what I like to do is give a great big thank you to Cassie for setting up the event, and to all of the people in the background at FAU for taking care of the event for us as well. They've been great in making it run very smoothly. You can give a big round of applause. I bet you could put up a hands up or something in the chat just to say thank you to Cassia and all the wonderful people at FAU. And, you know, it's funny because that's kind of the way things work at GeoGebra, right? All of you know that GeoGebra is really more than just a company. The bigger picture is that GeoGebra is a community. So, of course, I'd like to also mention that one thing that you might want to do is make sure that you sign up for the community program so that you can basically earn badges to show your pride for GeoGebra. You could become an ambassador or a you know, a participator of all different styles and types and levels. So you can find out more about the GeoGebra community program on the webpage. Let's see. Let's see, am I still sharing? Which screen? I'm trying, let me stop sharing and reshare again, because I think my sharing moved over to the wrong screen. That's the one I want to share. There we go. All righty. So you all have been working very hard today. I'll tell you, working very, very diligently, everybody. I've been here the whole day. The sessions have been amazing. Absolutely blew me away. So I think it's time for us to take about 40 minutes to relax and to play. Again, let me try to pull my chat over here. Hold on. There we go. So it's time to pull up and play. So you can see my screen. I want you to take a minute and think back to your youth. For me, that was a longer time ago than maybe for many of you. And put in the chat, what was the name of your favorite video game as a youth? I see Pac-Man coming up. Now, also, if you don't realize it, folks, your chat defaults to just chatting to the host. So make sure you are chatting to everyone. Asteroids is coming up. Blockout, Pong, of course, Mario Kart, Tetris, Mario Kart. These are awesome, right? Some of the great games that we all remember, you know, younger days when we were kids and playing all the different video games. Well, let's just take a second and define then what gamification is. Zelda, holy cow, there's a blast from the past. I don't even know what Superplex is. Millipede was one of my favorites. Gamification is basically adding elements of a game to an activity for students to increase or encourage their participation, right? And again, some of our presenters were talking about gamification earlier today. Burgess, of course, was showing how to use AR to get kids more involved. Steve Silvestri was showing some of the games that he's created, to keep the students more involved. I think back to my favorite games. Here we go. I put them in here. 1979, Space Invaders came out. 1981, Miss Pac-Man. How can you ever forget that sound? 1991, Sonic the Hedgehog. So popular that it became movies, right? Make movies out of it. Well, here's what I did. I'm, again, a very lucky guy. I am one of the people that works on GeoGebra resources and with GeoGebra resources, but I actually create very, very little. I've probably reached what I consider to be presenter status, where I'm smarter in that I know I don't create things as well as many other people, so I use what they created. And what I am going to do with this presentation basically is share with you a bunch of resources that are all games created by the GeoGebra community, giving everyone credit for free that you have access to. And the games that I picked specifically were not just games that were games for fun, although that's very important. These are games that I chose because they focus on content. So as you take a look at my slides, the first thing I do, they're all the same. I give the name of the game, the person or the creator of the game, if it's a one-player or a two-player game, in the United States, what math course it would probably be applicable to, what topics it includes, addition, subtraction, integers, and then a link to the game. And yes, I am going to put this whole presentation, which I've set together as a book, into the chat and post it on the GeoGebra website for all of you to have and play with. So don't worry about, writing any of these down now. You will get every one of them. Let's start off. Here's the first game that I found that I like that is very similar to 7th grade. You know what? I think what I'm going to do is split screen. See if I could do that so that you all could see. Well, I got to go back one. I'm going to go back. There we go. So this is, let me guess, it's going to take me a second to set myself up first. There we go. So here in this game, you set different levels, level 1, level 2, level 3, level 4, level 5. I'm not stupid. I'm going to start at level 1 because I don't want to make a fool out of myself. Begin the race. And it's integer operations, right? You're just adding integers, okay? If you get it wrong, you don't move. If you get it right, you advance. The faster you answer questions, the faster you advance. You can see, I think I am the blue spaceship. So I'm going to start to pass the red spaceship. And I think what happens at the different levels is the competing spaceship basically gets faster and faster, so it becomes harder to win. Also, I think the integers become more and more complex, but you can see that I am in the lead. I'm going to go fast. I'm not going to stay on any of these. You'll see I'll slow down and my opponent will start to catch up. Let's go to another game. Coins in a row. This is actually a 2-player game that I found that I think is fantastic. You'd play with another student, you shuffle the coins, and the idea of the game is that each player wants to make the most money in their bank. So I will play, of course, as both players, right? Because I'm not going to share this out to the crowd right now. So I am player 1 right now. Let me maximize this a little bit so you can see the coins bigger. I think I would rather take 15 cents. Let me enlarge it this way. I'd rather take 15 cents in my bank than 1 penny, so I'm going to click on 15. Now I am player 2, so the next child would or student would have a chance to go 50 cents or 1 penny. Again, there I'm going. Again, these come up randomly shuffled, so I know 10 cents is more. It put a penny all the way on that side this time. So I know I'm really going to want to stay away from that probably. Yeah. And I'm going to keep going because that's going to be the best way to go. The way these lined up that time, when it's done, it shows me who has how much money in the bank and who wins. So again, shuffle the coins and everything gets put in a different spot. So you have to know where to go and where to choose. A great 2-player game that's out there. Let's go to another one. Rubik's Cube. Now, I don't know about you, but I can't solve a Rubik's Cube. But I wanted to show you this activity because I think it's really fun. And I think your students will really like it. Of course, it's all about transformations, right? This is the way Rubik's Cube people talk about the different things to turn. So you can see I could turn the different pieces of the cube, right? I can also get different views of the cube with GeoGebra 3D. And this whole thing is basically created in GeoGebra 3D, the geometry tool, where, your student, you can see, this is a real good image because I'm spinning that side closest to me, and you can see the blue squares kind of spinning around in place. Now that's the middle one. So kind of really nice. Let's see. I just want to keep my eye on the chat also to make sure that I'm not missing. Both players have to log on. Oh, for the coin question, do both players have to log on? Well, no, because what you would do in that case is just have each kid turn to the device to them. They would share one tablet. I think would probably be the easiest way to use that, the coin game. Let's see what else we got. That's Rubik's Cube. Flop Flop. Mr. John Golden. Okay, this is a game having to do with transformations, basically where I think you have to change the line of reflection to make it so that the feet are correctly reflected, and then you would check. I mean, I'm pretty close, but not right there. So, it's made again to give the kids quick feedback, right? Flip flop. Let's see, that's 10th grade reflections and symmetry. Guess my rule. Function Machine, again, by John Golden. I've got a rule. Can you guess it, right? Oh, this is a very normally like a game that an algebra teacher would want to play. You can pick some inputs and I will tell you the output. This is the old function machine type of thing, right? So what's the input? 0. How many tries do you have? Type your non-zero input and then hit enter. So let's put in a 1. The output is 8. All right, guess my rule. Well, right now I'm thinking that I multiply by 8. Input is multiplied by 8, but I'm not so sure that that's going to stand when I change my other values. I'm just going to put +0 for now. I don't know really that I am correct. Check it. Not yet. All right. So now I've got to think. So it's not just multiplying by 8. All right. Anybody want to put another guess? What number from the chat? What should I put in next to kind of help our guess? If you enter into the chat, what number should we put next? Make sure you put in an 8. All right, let's put in an 8 and see what happens. Hold on. All right, when I put in an 8, the output is 29. So certainly it's not multiplied by 8 anymore, right? Certainly it's not multiplied by 8 anymore. I should probably be creating a table of values. If I was a teacher in my class, I would tell my students, well, start to create a table of values, right? I have 1, 8. I have 8 and 29. Any idea of the rule or another number to guess out there? I'm looking in the chat. Another number to use for my input or what the rule might be. I'm going to put in a 2. A 2 gives me an 11. Sorry. Yeah, 2 gives me 11. Times 3 plus 5. Let's see. Times 3 plus 5. Check it. Ha ha! Very nice. Thank you, Ben. Not so easy when you're trying to present and you're trying to get the rule, but you did a great job. There it is. Y equals 3. Okay. So this is what I love about presenting like this. Not only are people in the chat, of course, coming up with the answer when I have difficulty finding the answer while I'm speaking on microphone, but then they also take it one step further. So there, David just made me say, all right, so how can I differentiate this? Well, Ben found the function rule, but then David put it into the form of the equation of a line. If you look in the chat, that's beautiful. That's the idea. And again, this is all really nice thinking generated by playing a game. Let's go to another one. Whoops, hold on. Let's see. This is guess my rule. We did that. Here's one of Tim's interval notation quiz. Oh, this one is very mathy, but I still think it's really a lot of fun. What you do here with the slider, again, let me maximize it. What you do here with the slider is you change the zone. In other words, all to the left, solid to the left, open to the right, solid to the right, open with the center area there, closed, right? One side, the other side. So that's what the slider is doing. I've got this thing. So this is the union of these two inequalities. So you're talking about what? This is an algebra 2 type question, right? So I think we have something on, let's see, the union of those, not the intersection. Give me an answer here, people. You know what? I'm going to a new problem. Look at that. Ooh, that's nice. These are just, there we go. So I'm going to make my life easy. I'm going to go from negative infinity to 0. I'm going to move this from negative infinity to 0. Now, you notice I have a bracket on this side, right? So I do want to include the 0. So I have to change the slider and I get it correct. So again, immediate feedback, right? For formative assessments. And if you look at the randomization of these problems, you've got problems of all different levels. And again, in New York State, you're talking about an algebra 2 level type of problem. You know what I mean? And it, again, makes it a little bit more of a game, gives the kids immediate feedback, right? That's what it's all about. One player, grade 11, functions, graphs, inequalities, set theory. Beautiful. This one is actually in Japanese. One player, grades 3 through 9, algebra equations. Let's see what it is. Oh, so I just had to play with this one for a little while to see how it worked. Many of you are familiar with the physical version of this. This is a balance scale, right? So I'm going to start by putting weights on this side. So I've got a 3. Whoa, no, way not enough. Let's stick a 6 over there also on that side. All right, hold on, not enough. Stick the 10 on that side. Okay, hold on. Still not enough. Okay, what do I have to do? Well, let's stick this over here and check. All right, now I have a problem. So now I have to start taking things away. How much to move? I am correct. I moved the 3. Now look at the beauty of this activity. It says you balanced it. So now that you've balanced it, what's the weight in the bag? Anybody at home? $20, $36, $37, right? This is a 3 over here. I'm seeing it. Let's put it in and see what happens. 34. That's right. And then I could start a new one. I mean, how valuable is this, right? You're talking about adding and subtracting integers. I tell you, when I work in different schools for the younger grades, one of the biggest complaints teachers have is that the kids can't add or subtract integers without a calculator, right? Because in the US, we give them a calculator so early. Well, I believe that games and activities like that would certainly help that type of situation. Let's go to another one. Quadratic factoring game. One player, 9th grade, factoring quadratics. Let's see what it is. So here we use the slider. And this is basically, I mean, if you think about it, this is very straightforward factoring, right? I mean, this is really not that much different than factoring with a piece of paper. However, the kids play with it differently and they react with it differently, and they really think about it as a different type of situation than just doing another problem on a page. Somebody wrote these are all awesome. Okay, so Mel, thank you very much. I am a fan of you, Mel, and here's why. I didn't create any of these. All I did was do searches on GeoGebra's site and found a bunch of games that I thought I really liked because they focus specifically on math content. In other words, too often as a teacher, I saw games where I'm like, yeah, okay, I get it. It's a game, but really the content is not there. The content is lacking. Here, the content is full blown, right? I mean, this is quadratics. And I really think that if I gave this to my students, they would be more likely to do multiple problems like this than just factoring, right, on a piece of paper. Got it right. Look at that. Ooh, look at how nice. It even tells me that I could do it commutatively also, right? I could do x plus 3 and x plus 5. And then I could try another. And you know what? If I'm a student working on paper, I'm sorry, you people didn't know me when I was younger. When I was younger, if I was a student working on paper, I got one, I'm done. I don't need to do any more. But if I get to do it on here, I might do more. I might do a couple more and I might play. Log wars. So many times, teachers of higher level math classes think that you can't have gamification. You know what I mean? The content is too complicated. It's too difficult. Take a look at what I found here. Log wars. I love this game. I have to remember how to do it. Oh, it's simple. Which is greater? Now, here's what I liked about this also. Here, new game. John Golden set this up to be a 2-player game. Again, how would you do it 2 players? You'd share the device, right? Because this is not like on a multi-level playing. So first, I think I am the blue player. If I'm not mistaken, let's see, which one is larger? Let's say this is, right? Oh, by the way, they could be the same. The right one could be bigger or the left one could be bigger. I'm going to pretend. I'm going to just say the left is bigger. Check. Are you crazy? Okay, I guess I got it wrong. Okay. Yes. All right, let's get a new one. So by the way, when I did it the first time and got it wrong, I was the red player. When I got it right, I was the blue player. So now I'm the red player again. Okay, so which of these is bigger? Let's go here. Check. Okay, I got it right. New one. So you see, as the red player, my score just went up. My score just went up as the red player. Okay, so now I'm the blue player again. Let's see. I'm going to guess they're the same. What the heck? Check. Crazy? Okay, got it wrong. All right, so now I have to play as the red player. Got it right. The red player score goes up. So you could see, here it is, just all different examples of log problems, and it's been gamified. It's been one player against the other. Now, some people don't like playing the competitive type of game where it's one against the other. That's okay. I get it. You know what I mean? Some kids are nervous to lose. I know exactly what you mean. But, you know your kids, you know your situation. Think about how you want to do it. Let's take a look and see what else we got. By the way, Cassia, can you put in the chat or something what time I'm supposed to finish? I lost track of my clock. Let's go to field of fractions.
I didn't put it. You have still 15 minutes.
No, what time do I go into? I go until
you know the next speech is at 45.
4:45.
But people, but we need some time for chatting and some time for moving to another room.
For the younger kids, right? I think I put in there that this was for grades 3 through 5. So watch what you have to do. Find the part of the field that you're going to plant crops. I'm going to plant blueberries. Ted plowed 1/4 of the field. Okay, plow 1/4 of the field. Let's see how to do that. Let's plow it. So I'm using the arrows. There's half the field. That's 1/3 of the field. There's 1/4 of the field. So he plotted that much. Check. I'm good. Okay. Then he planted blueberries on 1/3 of the plowed part. Whoa, 1/3 of the plowed part. Okay, so there's my plowed part. Let's use my arrows. Well, there's half of the plowed part. Well, that would be 1/3 of the plowed part. Let me click in there. That's where I'm going to plant. And I got it right. Okay. And it goes on. What fraction of the whole field is planted with blueberries? Wow. You know what? I don't know. And it's difficult for me to see. So I'm going to ask for a hint by extending these lines. Oh, okay. Wait a minute. What part is blueberries? Well, that's one part there is blueberries. And now that I extended the lines, I could see there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 3 by 4, so it's 12. So it's 12 different parts. So there's 1 part blueberry out of the 12 parts. How did I do? I got it right. So what a fun activity for elementary school kids, right? To think about, and that was just problem number 1, to think about how to divide up and think about pieces of fractions. Again, I saw it. I was like, it's complete content. I love it. Placing whole numbers on the number line. John Albright. Oh, this is very cool. This is, well, you know what? This is a one person game because I know I'm pressed for time. I'm actually going to go to the next one because I think somebody took some version of that and made it a 2-person game. Wait, where is it? Now I'm going to go back to John's.
Hello, Robert.
Yes.
Will you share with us your book you created?
Cassie, I'm going to put the whole book out there. It's got all the links to every one of these games, and it's all in one whole book. Absolutely. Wonderful. Here's the only reason I don't want to do it now. They're going to start playing the games, Cassie, or they're not going to listen.
You are absolutely right.
All right. So let's do numbers. Let's go from 1 to 1,000. Let's place this many numbers. 4. Let's start. Okay. So where do I put 570? Well, that's 1,000. Okay. Wait a minute. So if that's 1,000, 500 is about here, right? So you know what? Let me go back. I think I made this game too difficult on myself. Watch what I'm going to do as a presenter. Hold on. I'm going to make it way easier. I'm going to make my upper limit 100. Way easier for me. I can't do 1,000. Let me start. So where's 5? Well, if that's 100, that's 50. Well, 5 is going to be way down here. Let me get the next number. 40. Well, I mean, 50 is like the middle, so 40 is probably a little bit down, right? Next number, 45. All right, it's going to be above 40, but not to that middle yet. Next number, 30. Well, that's going to be like below 40, but more below 40 than 45 was, probably twice below. Check your answers. Okay, and now it's giving me some kind of gauge of my estimation skills, right? And how well I'm estimating values. Right? Really, really cool. Next one. Find the results of this calculation. All operations, let's do addition only to make it easier on the host. All right, so let's see. Check your answer. -8 and 10. So we're talking about 2, right? Check your answer. And there it is. Looks like it's got it okay. And now it gives me a whole explanation. Try another. 8 and -10. Well, now we're talking -2. Check your answer. Okay, good. All right. And again, it gives me a whole explanation of addition, subtraction, and I could do this with multiplication, division, right? All operations with integers right there at your fingertips. Can you do negative integers? I don't know when that came up on the chat. I think it might have came up now. Let's do subtraction. Oh, I got it. I answered your question. Thank you very much. Good. All right, let's see. You know what happens? I get so into the games, honestly, that I stop reading the chat. Okay. All right. Oh, rounding. Ooh, there's another nice elementary skill. Round to the nearest. Now I can choose 100th, 1000th, right? I'm going to make it, easy on myself. I'm going to round to the nearest tens, okay? And I'm going to type my number in here. So I think to the nearest 10, that would be 13, 8. I'm going to get it wrong just to see what happens. 20. All right, let's see. Check. No, I got it wrong. Try again. All right, so I guess that goes up then. Maybe it's 30. All right, let me check. Now I got it right. And then I could ask for a new number. If I get good at rounding by tens, I can do my hundreds, my thousands, okay? This is all whole numbers. I don't know. I stopped looking after I found this one, but I would not be surprised if there's one out there for tenths also, right? I would have thought tenths would be, oh no, this is, sorry, that was tens. I saw what, hold on. Oh, I think, yeah, that's tens. I think it should be THS for tenths. Also, this is a great feedback on what other people have been teaching in these other sessions. If you don't like that and you want to take away that like TS, because you're like, it looks a little weird, you come up here, you copy the activity, you save it into yours, and now you can change it any way you want, right? You completely alter the activity, change it around to read any way and look any way you want, because once you've copied it, you can edit it. Beautiful. Let's go to another one. Decimals and fractions. Oh, this is cool. I think, let's see. Match each decimal and fraction to its equivalence percent. Click on the pair of cards. Okay, so this I think is like a concentration type of game, right? Let's see, 1/4, 0.25. Yes, right? So this is basically fraction decimal percent concentration, right? That's what I'm doing here. Let's get one wrong. 2/5, 75. Oh, that's not a match. Please try again. All right, 2/5, 40%. Beautiful. So here I am playing decimal concentration, right? That's 6th through 8th curriculum in the US, right? And a really nice, I mean, if you think about it, this is like 6 problems right here, 6 fractions to percent problems. Again, put it on a worksheet. Who wants to keep doing these? Put it as a concentration, whole other story. Estimating percents. David Cox. Let's see what you got, David. Play with this applet until you can consistently estimate less than 5% error. Wow, okay, here we go. So I have to move this dot. How big is 84%? Oh, wait a minute. 50%, 75%, 84. Try it. Did I get it? Look at this. He's giving me a chance and differentiating now. He's saying, well, look, put in these grid marks, put in these lines. I didn't do that. This is the game. Can you guess differently now? Can you guess better? Let's see. 10, 20, 30, 40, 50, 60, 70. There's 80. So, and that's 90. So I think, you know what? I'm going to take 84% up higher. I'm going to take, because that would be like 85%. So I'm going to take 84% just a little bit below. All right, check my answer. Original guess was 2% error. Revised guess, 0% error. I mean, it's amazing what is done here. And what I love about it is that he gives me another chance. Like it was hard without the tick marks. You know what I mean? So put in the tick marks now and think about if you want to readjust. What a beautiful game, David. Let's see what this is. Estimating percents. Oh, similar game. This is the one I was thinking about. John made this 2-player. So player A, let's see. In this game, two players. So the show 30%. Let's see, 10, 20, 30%. Wait, maybe I got to do a new game. All right, hold on. In this game, players try to show the target percentage on the number line. Your score is how far off you are. Okay, so 42%. 10, 20, 30, 40. I'm doing something wrong on this game because it's giving me the answer right away. Oh, here, play. You know what? Don't drink so much coffee before you do a presentation, Rob. You won't be so excited. You won't miss the play button. Here, 42%, 20, 10, 20, 30, 40, 50. So 42. Maybe the blue player picks his to be, no, I think that's 42. Score it. Player 1 was off by 0.2. Player 2 was off by 0.8. Next round, 31%. Ooh, look at this. They changed the tick marks. So that's 50%. I guess it's 25%. I don't know. I'm going to say there. And then player B maybe will make their guess wherever they want to go. Score it. Player A, the red one was off by 0.4. B was off by 2.8. What a nice way to teach estimation. Let me find another. Only 1s, 2s, 3s, and 4s. Oh, this is cool. You see the numbers dropping? I need to make 7 fast. Here, 4 plus, oh no, I did that wrong. Here, reset. 7. Oh, what is 8 my target? I have to read the directions. Let me go back. No directions. All right, we'll figure it out. That's not a problem. 7, 4. Oh, I think maybe my target is 8. Minus 4. I can't do it now. Minus 3. Let me reset. My target is 8. So 7 plus 1. Got it. Continue. 8. And my target is 4. Minus 4. Got it. Continue. I have 4. Let's get it wrong. Watch what happens. By the way, you'll notice as I do some of these, they are not in my native language. That's okay. You could see how easy they are made, how well they are made, and how easy they are to figure out, right? So it came down to the bottom. I didn't make it. I didn't make the score in time, right? That's what's going on. So let me tell you something. You know, some of the other presenters were talking about all the wonderful places they've got to travel to. I'll tell you the truth about Rob Pontecorvo. I am sheltered. I am a local. I don't get out. It's very sad. You should feel for me. However, I don't speak any of these languages that some of these games are created in, and I still could easily figure out what's going on because they are created so nicely. Let's see, and learn a new language in the process. I really should. All right, so this one is really cool, right? So what I put this up here for the non-math people, right? You are basically supposed to use the red, blue, green sliders to change the color of the top square to match the color of the bottom square. I mean, what a great tool for like an art student. I mean, to me, those look dead on. I'm not very good with colors. Let me check it. Not yet. All right, so I guess I got to do something. I got to make something darker. Maybe not that one. Maybe I have to add more red. I don't know. Right? Oh, I mean, that. Honestly, people at home, I don't see the difference between those two. Let me check it. Still not yet. All right. So basically, you know, if I was an art student, I would need to match those colors pretty well, and then it will give me the response when I get there. And again, you just pull up a new color, right? Oh, look, it tells me red, green are multiples of 5. Okay, so it's giving me a hint. I mean, I put that up there again because I thought it was cool, even though it's not even really for math people. Let's see what else we got. Let's go to another one. Adding and subtracting.
Sorry, Rob, I have to interfere. We have 5 minutes to the next session. Maybe.
All right, so Cassie, because I'm going to share this book, I just want to end with one that Monique has recently made for me, and I'll show you what I mean. So many of you might use in school what's called a 9-square puzzle. Okay. Basically, I was explaining to Monique one day about a 9-square puzzle and how they were, and she created a 9-square puzzle template maker. And here's the idea behind 9-square puzzles. Yeah, let's just click on this one. This is one that Samantha Cruz already created for us to show in Spanish. Basically, what you have to do is move the pieces around. If you click on them, they will rotate. And this one is for the Spanish vocabulary. So you have to match the edges to the correct words. Let me see if I can find one that's really easy. I think there was one in science. Yeah, this is a small one. All right, the molecular names. So I'm going to put the one that's got 4 sides in the middle. Now, I'm going to ask for help, people. Does anybody know here what is gypsum? This one's too hard. I didn't want to do this one. I wanted to do the easier one. Let me go back. Yeah, believe it or not, this one I would probably do better. But this is for you chemistry teachers, where basically you'd match like the number, the name, the symbol, what O is oxygen, I guess you call that the symbol, to the word oxygen. And you put the puzzle together by having the matching sides adjacent to each other. Here's what I want to do. I want to go quickly to my, I'm going to share right now the link to the games. Hold on before I leave. Where are my games? Not that. I want to go to a different profile, the GeoGebra profile. I'm going to go to GeoGebra. Find that book. Gamification top picks. Here we go. Share. Copy. Stick that in the chat. Chatting to everyone. But Cassia will also be given this to post out to everyone. Paste. There is Rob Pontecorvo's top pick of games that relate directly, completely, closely to our curriculum in the U.S. based on different grade levels.
Bravo.
Thank you very much.
Wonderful talk. Thank you so much, Rob.
Cassia.
You really make us going to GeoGebra so many games. Did you know that?
I'm sorry. Hold on. I gotta lower my music. I'm being very bad. I'm sorry. Say it again.
Great idea to share these games with us and talking about, how they can help with mathematics. And, we all need to spice up our lessons. Thank you so much, Rob.
My pleasure. My pleasure. Thank you.
And see you in the next talk. Yes, we have in 2 minutes next talk. So we have to finish. Thank you so much.
Have a great weekend, everybody. Thank you.
Thank you so much. Thank you. I appreciate it. Very nice.